All right, this is section 3.2, day 1, and we're just going to start to get into logarithms. So we've kind of focused the first day on exponentials, and now we need to talk about the inverse of an exponent, which is a log. So the log function is what undoes exponential functions. So log functions are the inverses to exponential, and then vice versa. And we can use exponential form and logarithmic form to switch back and forth between the two, and that's super important when we go to solve stuff. Sometimes it's really difficult to solve it as a log, so we'll switch it into an exponent, and then it's much easier to solve. So these are the two representations, and kind of paying attention to where all of these variables end up when you switch to logarithmic form. So the base to the exponent, which is the a, that's called the base, becomes the base of the log. So that one's kind of straightforward. That makes sense. And then as you're switching things, the only thing I can really tell you is if you were equal to y over here, you cannot be equal to y over here. So y and x are going to have to switch places. Every single variable that you have here finds a new home in logarithmic form, and vice versa. So if you were equal to x over here, you cannot be equal to x over here. So the exponent actually becomes your equal, and then over here the thing you were equal to becomes what you're taking the log of. And it seems a little abstract at first. I kind of agree with you. And then down here we're going to switch back and forth between the two forms 8 different times, so hopefully by then it kind of sticks about how and where you put all of the pieces. There are two different types of logs we need to talk about, and they're the two that end up on your calculator or show up on your calculator. So you have two buttons for log, and they're actually located, well, on a graphing calculator, they're located right here. You have a log button, and then you have an ln button, and those are the two types of logs that your calculator is set up to do. And the common log is the log button. So that's the one on your calculator. It is known as log base 10, the common log. So if we don't write a base for a particular log, it is understood that that base is 10. Natural log is written as an ln, and it is understood to be log base e, which is another important value that we use in exponentials quite a bit. And e is just a number. It's kind of like pi. You can't solve for it, so e has already been discovered. It is about 2.71 ... It's got a lot of decimals just like pi does. So these are the two different log buttons that you have in your calculator, and the two different types that they are. One is log base 10, that's your common log, and then you have log base e, that's called your natural log. So now we're just going to practice switching between the two forms. So can we change this log into exponential form? So I'm going to start with the base, which becomes the new base. What I was equal to becomes the power, and what I was taking the log of, that's my new equal to. So as you're switching these, there's nothing for us to solve. We're just switching them. And then they do have to come out to be a true statement. So if you by accident maybe messed things up and did 4 to the 16th equals 2, you could know right away that can't be true. 4 to the 16th power, there's no way that's a 2. Or 2 to the 16th equals 4. So your statement needs to be true when you're done. So make sure that you kind of just double check that as you're putting all the pieces in their different places. Next up is an exponential, so we're going to change it to a log. Base becomes base, and then these two swap places. So 125 equals 3. Next up, base becomes the new base. Exponent is what we're equal to, and now we're equal to 1 over 81. Log with a base 24, and then 1 and 0, they just need to swap places. ln is, remember up here, it's just log base e, so I'm just going to change that to a log base e. I'm still in log form. I haven't changed yet. I just rewrote that. Now I'm going to change to exponential. So e to the 0 equals 1. So this was just a swap out, swapping out ln for log base e so that I could see that little base so that I could raise it to that power. So this one's going to be log base e of 54.6 is about 4. You could also write ln of 54.6 is about 4. So those mean the same thing. I don't care which way you write it. You can either write log base e or you can write ln. Here's another ln. I'm just going to change that to be log base e. I have not converted it yet. I just rewrote it. Now I'm going to switch it to exponents. Last one, I've got e to the first, so that's going to change into a log base e of 2.72 is about equal to 1. And that could also be written as natural log of 2.72 is about 1. There are a couple properties of logs we need to talk about. So anytime you are doing the log, and it does not matter which base it is, 8, E, 10, 47, If you're trying to log 1, that answer will always be 0. It's almost like saying a to the what power will be a 1, and any number, when you raise it to an exponent, the only way to get a 1 is to put a 0 there. So that's 0. Since logs and exponents are each other's inverses, they're the undoers. Anytime you have a log base matching up with an exponent base, those actually cancel out, and you're just left with whatever's left over. The same happens in reverse. If you have a base and then you have a log base, so the base of your exponent and the base of your log match, they also cancel, and whatever's left is your leftovers. Last one for properties, we have if log a of x equals log a of y. So if the logs are exactly the same, then the x and the y have to be the same, whatever they are in terms of a quantity. Now we're just going to do a couple of evaluating. This time we're actually going to solve. And sometimes when it's written in log form, it's really difficult to see what the answer might be. So if you switch to exponents, sometimes it's a little bit easier to tell. And so 2 to the what power? So we're literally asking 2 times 2 times 2. How many 2's does it take to get to 8? And that would be 3. It might be worth noting there or writing down, it's really easy to accidentally slip into multiply. I'll have a lot of students say, well, it's 2 times 4 that would get me to 8. I'm like, you're absolutely right, but we are talking about an exponent. So make sure you're thinking about what power do I need to have on that 2 to get to an 8. Next up, I have another log. I don't know what log base 2 of x is. I don't know what that would need to be to make me a 2. So I'm going to switch to exponents. So 2 to the second equals x. And now that's much easier to see. That's just 4. So oftentimes being in logarithmic is not easy to tell what to do. So switching to exponentials actually kind of gives you another avenue to look at the same problem. I'm going to do the same thing here. I'm going to switch to exponents. I don't know why I wrote an e. 2 to the x equals 0.25. And fractions, decimals are not really our friend. Good gracious, I did it twice. Decimals are not really our friend in this chapter. We would prefer the fraction. So I'm going to write 2 to the x, and then I'm going to change this to 1/4, which seems super counterproductive. You guys prefer decimals. They're easier to look at. But the fraction, actually, we talked in the previous lesson that when I turn that upside down, it would become 4 to the negative 1. So anytime you flip a fraction upside down, so instead of being 1/4, now it's 4/1. If I do that, then I have to just change the exponent to be negative. I'm not sure where that's getting us yet, Miller. Well, 2 and 4 are very closely related, like first cousins related. They're not quite identical, but 4 really is just a 2 kind of disguised. So I'm going to keep my 2 to the x. I know 4 is really just 2 squared. So I'm just rewriting 4 as 2 squared, and then there's still that negative 1 up there. So that still came with. So all I did was kind of just rewrite the 4 as a 2 squared. And anytime I can get the bases to match, when those are the same, it then means that your exponents have to be the same. So x has to equal 2 times negative 1, or x is just negative 2. Sorry, squeeze that in there. Next up, I've got natural log of x equals 3. Sometimes it's tough to see until you get that log base. So I haven't solved or done anything yet. I just changed that natural log into log base e. I'm going to switch to exponents, so e to the third equals x. And then I'm just going to type that one in. E to the third. And I got about 20.09. Last one, I've got a root on it, and we need to talk about what that's going to look like. So let's switch to exponents, and then I've got square root of 3. If you don't remember, square roots can actually be rewritten as fractions. So a fractional exponent, which seems a little like, oh my word, why would I want to do that? But we would rather have an exponent in this chapter than we would a square root. So if I have the square root of x, that would just be a half power. If I was doing the cubed root of x, I would have a third power. Fourth root of x, fourth power, and so on. So this being a square root is going to be a 1/2 power. And now that I have my bases the same, that means my exponents have to be, so x is a half. One more to do is something called the change of base formula. So since our calculator can only compute logarithms in terms of base 10, actually, and base e, so they can also do natural log, we need something to help us turn other bases into something we can use. So here I've got log base 8 of 5. Even if I were to set that equal to x and then say, well, I'll just switch it into exponents, I'm not sure what exponent that would need to be in order for me to come up with what could I possibly raise that to that would turn this 8 into a 5. So it seems a little far-fetched. That's a little difficult for me to do. So what we do is called the change of base formula. So instead of being base 8, which I don't have a button for in my calculator, I can fool my calculator into doing the problem by doing the change of base formula, which looks like this. So I'm going to take the log base 5, and this is the large number font size. So large font goes on top, small font goes on the bottom, or the base goes on the bottom. And if I do that, this is implied that this is log base 10, which is the button on your calculator. So we're just going to do log 5 divided by log of 8. What you probably want to keep in mind is how you plug it in. If you don't get the parentheses in the right place, it's going to get a little messed up. So I do log of 5, excuse me, and I hit enter, and then I hit divided by the log of 8. That way I'm making sure that since my calculator threw a parenthesis in there, if I don't forget to close that, it'll mess up my answer. So I'm just kind of doing them separately to divide. And I get about 0.77, let's say 4. So that change of base formula allows me to deal with bases that are not 10 or e. I should say base 10 or e. So that's your first step into logarithms, doing a lot of switching between exponential form and logarithmic form in order to solve some problems.